All right, here's question number 15. We're going to write this calculus friendly. So 2 plus x to the negative 1, and then x to the negative 2 dx. The hook comes from inside the parentheses. The derivative of 2 is 0, but the derivative of x to the negative 1 is negative x to the negative 2. That's the hook I need. And if I see what's before and what's there, they're almost the same. It just needs a negative in front. And then a negative times a negative, they would match then. So we need a negative in front to make them the same. And then I circle the hook, I unhook it. So the answer starts with a negative. I add 1 to the exponent and divide. And then the constant. Number 16. In number 16, again, you should always press pause, write it down. I'm ready to go. If you're not ready, you should press pause and write the question down. Inside the parentheses, the hook, the derivative, pi is just a number, like 2 or 3. So when you take the derivative, the answer is pi. That's the hook. The hook is correct. So it's ready to go. The hook goes away. The antiderivative of sine is negative cosine, and that's it, plus c. So you have to know, for trigonometry, you have to know the rule. It's not the power rule necessarily where you add 1 and then divide. Number 17, press pause and write it down. We're going to write this a little friendlier. So it's x to the negative 1. And then this is x to the negative 2. The derivative inside the parentheses is negative x and then to the negative 2. Did we just do this one? No. Feels like we just did that one because of that, right? All right. So we need a negative in front so that they match, and then I can unhook it. And then the derivative rule for cosine is sine plus c. Felt like I just did that one. Number 18. Again, press pause and write the question down. The hook comes from inside the parentheses. These have to match to integrate. This is a rule, secant tangent. The hook is the derivative of 2x minus 1, which is 2. And then what was it before and what did it become? We need a 1/2. Then we can unhook, and the answer starts with 1/2. The antiderivative rule for secant tangent is just secant, and it's 2x minus 1, and then the constant. Number 19. Write it down, press pause, right? Write it down, then we start. Inside the parentheses, the derivative of tangent is secant squared, so that's the hook. Unhook it. And then I add 1 to the exponent and divide, and then the constant. I know, it's nice when you see it, right? Number 20. Press pause, write it down, then press play. So for this one, I'm going to write it cotangent. The derivative of cotangent is cosecant squared, so I see that relationship. I'm going to write this to the negative 4. And then the derivative of cotangent is cosecant squared, so I can unhook it. The antiderivative rule here would just be the power rule. So you're adding 1. That's negative 3. Oops. And then divide by negative 3, and then don't forget the constant. 21, press pause, write it down, and we'll do it together. Here's an example that if you do the hook, they're not like terms. So the hook is 1 that doesn't match. So I have to do a u substitution. So inside the parentheses, I'm missing calculus friendly here. All right, 1/2 instead of square root. U is going to be x plus 1. Subtract 1, x is equal to u minus 1. And then take the derivative of x, the derivative of u, the derivative of negative 1 is 0, and then do a substitution. So x is u minus 1, x plus 1 is u, and dx is du. Now we're going to distribute. This 30, if we want, can go in front. Get it out of the way. U to the half times u. You add the exponents. Negative 1 times u to the half. And then at this step, we can do the integration rule. So we're going to add 1, and then instead of dividing the reciprocal, I'm going to add 1 instead of dividing the reciprocal, and then the constant. And then the last step, we're going to put x's back in. So u is x plus 1, and that's our last step. Ta-da! Number 22. I hadn't written that one down yet. So for number 22, I'm going to write it calculus friendly right away. So that's 3x subtract 5. That's 1/2 x subtract 1 to the negative 1/2. Take the derivative, and they're unlike terms, so it's u substitution. So u equals 1/2 x subtract 1. The derivative, x, I'm going to add 1 and then multiply everything by 2. So 2u plus 2 is equal to x. So we need this, and then the derivative of 2u is 2 du. The derivative of 2 is 0, and the derivative of x is dx. So this is what I need. Then I come back to the question. So x is 2u plus 2. 1/2 x subtract 1 is just u. And then dx is 2 du. Again, I can put the 2 in front just to get out of the way. All right, now some algebra. So 3 times 2 is 6u. 3 times 2 is 6. Take away 5 is 1. Distribute. So u to the 1/2 times here we add the exponents. So that's 6u to the positive 1/2. 1 times u to the negative 1/2 is just that, u to the negative 1/2. And now we are going to integrate. Oops, I almost did integration sign. So we have 6. I'm going to leave a space. Add 1, that's 3 over 2. Instead of dividing times the reciprocal, I'm going to leave a little space. Add 1, that's positive 1/2, divide or by the reciprocal, and then the constant. And then the last step, this is 12 divided by 3, so that's 4. Put in what u equals, which is 1/2 x minus 1. And then if you like, you can now distribute the 2. So that's 8. The exponent 3/2 means I can't distribute there. 2 times 2 is 4. Again, the exponent 1/2 means I can't distribute there. And you have your answer. All right, 23. One more time. In number 23, you're integrating 5x subtract 8. And I'm going to make it calculus friendly. It's a u substitution question, so u equals 1 minus x. I'm going to add x, and I'm going to subtract u to get x by itself. And then the derivative of x is equal to negative derivative of u. I come back here, plug in for x, 1 minus u. 1 minus x is u. And then dx is negative du. I'll put that negative in front. And now we're ready to go. So now some algebra. So 5 times 1, take away 8. And then 5 times negative u. Distribute. So negative 3 times u to the half. Add the exponents. That's negative 5, 3 over 2. at this step, we're going to integrate. I'm going to leave a little space. Add 1, that's 3 over 2. Divide, or the reciprocal. Leave a little space. Add 1. Divide, or the reciprocal. And then the constant. And then the last step is to plug what u is equal to. So a negative times a negative. This is 6 divided by 3, or the 3's crossed out. That's positive 2. And then u is 1 minus x. Again, a negative times a negative, and the 5's cross out. That's positive 2. And then u, again, is 1 minus x to the 5 over 2. And then the constant. That's it. 24. I think I'll get like 2 more questions done for this, and then I'll do another video. So the second derivative, x to the negative 4/3. The derivative at 8 is 3 over 2. The function at 27 is equal to 5. So my goal is to find f at x. So first I need to work back one step at a time. I'm going to do the integration of the second derivative. So I'm going to add 1 to the exponent. So negative 4 plus 3 is negative 1/3 instead of dividing the reciprocal. And then the constant. I'm going to plug in 8 and make it equal to 3 over 2. The cube root of 8 is 2, but the negative exponent, you do the reciprocal. So this is negative 3 over 2. I'm then going to add 3 over 2 to the other side. I have common denominators, so 3 plus 3. So c is equal to 3. So now I know the first derivative. So it's negative 3x to the negative 1/3 plus 3. To find f at x, I integrate the derivative, first derivative, this. So I'm going to add 1, that's positive 2/3. I'm going to leave a little space. And then instead of dividing times the reciprocal, the antiderivative of 3 is just 3x, and then the constant. I'm going to plug in what I know. So I know 27 and 5. So I have negative 9 over 2. I got 27 to the 2/3. I got 27. And I'm going to make it equal to 5. And that's what I'm going to solve. So the cube root of 27 is 3. And 3 squared is 9. So the cube root of 27 is 3. And then 3 squared is 9. So when I multiply it, that's the answer I get. Negative 81 over 2 plus 81 is actually positive 81 over 2. You could also change it to a decimal. And then subtract. So half of 81 is 40.5. So if I subtract it, what is it? Negative 36.5. Is that right? $30.5. What? 35.5. No, 36.5. Right? 35.5. It's 35.5. It's like fighting with myself. So put it all together. You have negative 9 over 2x to the 2/3 plus 3x subtract 35.5, or you can write it as a fraction. Sometimes decimals are easier. All right. 25, this will be your last one. And then I'll do another video for 26 and on. So the derivative is this. And you have a 0.25, and you're supposed to, on the function, find the function. So I'm going to take that, to find the function, I'm going to integrate this. And so I need to write it friendlier. write this down. The hook should be 2x from the base. What it was 6x, so what it was over what it became, so 6 divided by 2. Then I can unhook this, add 1. Instead of dividing times the reciprocal, and then the constant, that's f at x. At this step, we can plug in the point. So the 3's cross out, so we have 2, x is 2, and it's equal to 5. So 4 take away 3 is 1. 1 to any exponent is 1, so this is just 2. So subtract 2, and c is equal to 3, and then you put it all together. So that would be 2x squared minus 3, 3 halves, and then c is 3 from here. So I write this down, and then I put down what c equals. Oops, c is 3. Why didn't I write down 3? There it is. 3. Mr. G Math over and out. I'm proud of you for doing your work. Till next time.